Hello and welcome to Nick Maths 101. And now we are going to study about vector addition based on the Oxford Dictionary. A vector is a quantity that has both magnitude and direction. So vector addition is going to be about a directed line segment in which we will calculate its magnitude and direction. We are also going to cover how to use vector addition by components and using the law of cosines as well. Vector is different from scalar. Since scalar has no direction, for example.
Wait, I don't think they'll be needing that scalar, mostly about scalar, because we're focusing on vector addition. It's about vector, and this is math class, not physics class.
Well, yeah, that's a good point. But the student must know the example of scalar as well. For example, is the distance, volume, time.
Yeah, but I don't think they'll be needing now because they're focusing on vector, so I'm just going to close you right now.
No!
Goodbye.
No!
Okay, so basically what he says is right, all about vector, scalar. Yeah, it's right, but I don't think we're going to focus on scalar for now. We're just going to focus more on the vector itself, and we're going to focus on not the definitions, but more only to the mathematical way, because this is math class. Yeah, this is math class. So today I'm going to review how to do that, how to calculate the vector addition and all of that. What? We're rolling? Why didn't you? Selamat pagi, siang, atau malam. Okay, so welcome back to Nick Maths. Now I'm going to tell you about how to use vector addition in a mathematical way, thus also using it for a real-world problem situation. So the formula needed for this lesson is the first one is going to be r equals x cos theta I plus x sin theta j, which is the components of vector addition. This is going to be new. Second one is the r squared equals a squared plus b. Basically, technically, just the law of cosines and also the Pythagorean theorem. And so basically it's easier for me to just put it in a question because we already talked about the definitions in the beginning, and I'm going to talk about how to put it in a particular situation. Okay, so I have a RC boat that I've been using, and let's say this RC boat, I make it move outwards for 11 centimeters. And then after that, we can see the stream of water is pushing it 8 centimeters away to the downwards direction, in which we will call it the B vector. Okay, the first one is the A vector, by the way, I forgot to say that. And of course, after this, the boat will somewhere be in that position. And now, by using vector addition, I want to find out what is the displacement from one place to the other place. And by also knowing that 11 centimeters and 8 centimeters, vector A and vector B has a 73 degrees distance towards it. Okay, so we're also going to find out what is the angle A, meaning the vector A towards the resultant, on which angle is the boat at. Okay, so I put it in a graphic to make it easier for me and for all of us to actually see it. So I put it in the graphic position. I have A vector 7 centimeters, B vector 11 centimeters, and theta is 73 degrees for this one. Okay, so I put this graphic first, so I'm just going to draw a triangle on it just to make it easier for this because we're going to use the law of cosines for this one. Vector A is going to be the red one. Vector blue, which is the B one, is going downwards in that direction. Okay, so if you can see the graphic through that one, I forgot to put the resultant, by the way, on the graphic. And so afterwards, we're going to draw the green resultant angle, resultant vector from A and B. Okay. So I'm basically using the back section of the graphic itself. If you can see, the A is that way and B is that way, so you can use it from the back one. Okay, so for this one is the law of cosines. If I can recall correctly, oh yeah, before that, let's just go on with the A. Theta is going to be at that position, which is between A and B. If I extend the line right there, it's going to be 73 degrees. Okay, it's different with the one inside because that's the one we're looking for later on. The A is 7 centimeters, the B is going to be 11 centimeters, and the resultant is going to be the one that we're going to find. But how do we calculate this? So first of all, we have to find the angle first. How do we find the angle inside of that, in between 7 and 11? Which is, it's 711. Okay, 180 minus 73 degrees is equals to 107 degrees, because you know that a triangle has 180 degrees, and that the theta is 73, therefore 100 minus 73 is going to be 107, which is just simple math. Okay, I know you're all using this with your minds and all of that. Yes. Okay, so what configuration am I using for this one? If I may know. Wait. Oh, this is a video? Oh, so I'm talking to. Oh, so talk to. Okay, got it. Okay, so I'm going to talk to my future self and my future friends right now, and I'm going to answer it by myself. It's going to be SAS configuration. Okay, so we're going to be using the law of cosines for this one. C squared equals A squared plus B squared minus 2AB cos C. Probably you all already know that from the presentation of Josh last Friday. And R squared equals 7 squared plus 11 squared minus 2, 7, 11 cos 107 degrees. So this is what the form is if I put the information that I already have inside that equation. Okay, so this is going to be triangle. And now by using simple math and algebra, R equals square root of 170 minus 154 cos 107 degrees. Therefore, if you can input it in a calculator, or if you can use your mind, if you're smart, or if you're genius, R equals 14.664 centimeters. Okay, so this is pretty straightforward, just doing this. And by using the law of cosines, you can already found out what is the vector R's magnitude for this one. Okay, so now I will want to be using a B angle. So I'm going to use B angle because I want to find out what is between the A angle and the resultant angle. So with what degrees it is at. Okay, so now all we have to do is to find the angle B. So we're going to find angle B right here. But the problem is, how do we find the angle B? Cos B? Wait, oh well, let's just call CC. Okay, let's just call. I'm using earphones, hold on. Jello!
Yo!
Hello!
Hello, sister! What's up?
Yes, okay. So basically, I wanted to ask, how do we find the angle B in this case? I just get a little bit confused after doing vector addition and stuff. Now I'm confused on how to find the angle. Can you help me find the angle?
Actually, we just use the law of cosines, I believe. So, cos B equals to 14.664 squared plus squared minus 11 squared. And you can calculate that first. And divide the whole thing by 2 times by 14.6 times 7. Yeah, calculator lah, bro. If you don't use calculator, you should use calculator.
Oh, okay, I got it. So basically, we're just going to alter the law of cosines, right? Like kind of swap the place and all that.
Yeah, bro.
Okay, I got it. Thank you. Bye-bye.
Yo, bye.
Okay, so basically the answer that we're going to have is 45.867 because of the help of CC earlier. Cos inverse of 0.696 is 45.867, and why did you do this? No, we talked about this. This isn't funny. Stop doing retro. It's already an old meme. Okay? Can you just please close it? Thank you. I'm sorry for that technical issue. Okay, so I have the second question. If r equals 21 units at 70 degrees and s equals 40 units at 120 degrees, find what is r plus s. Okay, so this one we can actually just use the components. It's just going to be something new that I'm going to tell you right now. R is equals to x cos theta I plus this x sin theta j. So from this one, what is the x? X is technically the units that you'll be using, and theta is going to be the degrees. Okay, so well, yeah, basically this is going to be something actually really pretty straightforward if you can do this correctly. So r is technically, vector r is technically 21 units cos of 70 degrees, because you can see from the question r equals 21 units at 70 degrees. Therefore, we know that r has units of 21 units and 70 degrees j. So therefore you can see the equation on the above section right now. And now we are going to find out what is r. Technically you can just put it in the calculator and all that, and you can get 7.182i plus 19.734 j. Okay, so I'm just gonna box that, so it's going to be very easy. You guys can know it and you guys won't get confused. And s is going to be 40 cos 120 degrees. Why is that? Because if you can read the question, s is equals to 40 units at 120 degrees, which is very simple. Which is plus by 40 sin 120, s by calculator equals negative 20i plus 34.641 j. So you can just box that out just to make it clear and all that. Now, I would wonder, what is the next step? What should we do on this one? So you just have to add the r plus s, because the vector r plus vector s is equals to the resultant vector. Because if you have one going that direction and the other going in that direction, then what is going to be the middle? It's just the addition. Okay, so basically in the vector r and the vector s, we have to plus or add the components of those vectors. And now, by using the big brain of mine, I will calculate. How to calculate this? I use Revelation. Yes, okay. And now, r plus s vector equals negative 12.818i plus 54.375 j. Yes, okay. So we're just going to go back here and we're going to find out what is the tangent. I mean, how to calculate if we already have the magnet, already have the what's called the equation, the components. Then how are we going to find the magnitude and or direction? Oh, sorry, before that I forgot to add in a question. We are supposed to find out what is its magnitude and what is its direction, okay? So, from the equation above, a vector r plus vector s equals negative 12.818i plus 54.375 j. How do we do this? We just use the Pythagorean theorem, okay? A squared equals b squared plus c squared. So, of course, you guys already know this and all that. And now, basically, the A is going to be the r plus s, technically. So, r plus s vector, which let's say is just the A, to replace the A, is equals to negative 12 square root, square root, because we're just going to make this very simple. Square root, just simplify it so that, yeah, it won't take a long time. It's going to be negative 12.818i squared plus 54.375 squared, as you guys can see from the 12.18818 and so on from the I and J. And therefore, if you can put it in the calculator, you have 55.865 units. And that is how we find the magnitude. Very simple. And on the direction. For the direction, we're going to use tangent inverse. But the problem is tangent. what unit should I put it in? You know that tangent is sine over cosine, let's say. But wondering about that, how do we put it in? I mean, like, you put the j section first, or you put the I section, or what number you're supposed to put in? Okay, so this is where it comes place. As you can see from the format of the components, we can see that for the cos 120, which is cos first plus sin next, right? The sin is on the j1, the cos is on the I section. So we know also that tangent is opposite over hypotenuse, or sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So tan equals to sine over cos, because tan is opposite over adjacent. Because by simplification you can do that. And knowing that the j is the sine section and the I is the cosine section, therefore we can conclude that tangent is going to be the j over the I. Get it? So it's going to be the j, the j component unit, which is 54.375, over the I1, which is negative 12.818. And therefore, if you can just put it in a calculator, because I don't think you use your brain for this one, because that's a long decimal in the tangent, because negative 76.7356 degrees. Now, before I went any further, I would like to ask, can a degree be negative? Of course not. Stop! Before I continue on, I can see all you guys in that little screen. Yes, I know some of you are very bored with this presentation and you guys probably are sleepy, but I do this so you guys can be awake and you can be attention and you can write more notes so you can be smarter. Yes. Okay, so if you put it in a graphical case, let's say, I'm going to draw this Cartesian right here, and we're going to draw. Okay, before we're going to draw, we're just going to find out what is a SPA. As you can see that we have already learned this from previous lessons with I forget if it's Harmin one or someone who actually explained about the standard position of an angle. So by using tangent, of course, we know that the adjacent is going to be negative 0.818, which is going to be on the left section of the Cartesian. Sorry, for the Cartesian, I forgot to put the U or the XY labels on that one. But yeah, I mean, you guys understand, okay? Please don't degrade me on this one. So technically, if we know that the cosine is negative 12.818, which is the adjacent section, we know that the sine is going to be the vertical section, because opposite over adjacent, you get it? Because it's opposite. Okay, 54.375 is going to be the length of the upper section. As you can see, when I draw that point right there, okay, this is not to scale first, okay, because if it's to scale, then it's weird. Okay, moving on, we know that it's going to be on the second quadrant, and 76.7356 is going to be the angle between that right there. You can see the Cartesian right there. And afterwards, for this one, just keep in mind that vector addition does not use reference angle that we learned in radian or something else. So technically for this one, we're going to use, the theta is going to be that section right from the standard point of an angle to the angle that we already made, which is going to be, just added 180 minus 76.7356, therefore we get 103.264 degrees as its direction. Okay, please keep in mind that this point right here is very important. Just keep in mind on this one that every time we have it on the second quadrant or the third quadrant, when you draw the graphic, it will always be added by 180 degrees. If you draw the line and it's on the first and the fourth quadrant, then you don't have, or you really don't need to add it with 180 degrees. You just have to just let what the angle is and just let it be. That's the answer. But if it's second and third, because it's negative, we're going to have it with 180 degrees. Like on last Thursday, I guess, or Wednesday, Marcelo's presentation about that one. It's similar to that kind. But now if some people ask, what is a bearing? What is a standard position of an angle? You know, sometimes the book asks, or questions ask, what is a bearing? It's technically a standard position of an angle. But if we know the standard position angle is on that section right there, on the graphic that I drew, and the bearing is the one on the y-axis. So it's technically the same principle with SPA, but the difference is just the position. The SPA starts from the x-axis from that section, the positive x-axis, and the bearing is the positive y-axis, starting from that one. And so basically that's all you need. You can either use bearing or SPA, it doesn't really matter, as long as you're consistent. Like from what I did, I used SPA on this question particularly, and you have to be consistent to the ending. Okay, so if it's second and third quadrant for the SPA, then you have to add 180. Bearing is going to be the third and fourth. Yeah, I don't know. I just don't want to confuse you, but I think I prefer SPA better in this. And so basically, yeah, SPA is better, honestly, if you guys know, because it's more easier to do. And so basically, that's my presentation for vector addition. I hope you understand. I hope I'm not being a bad teacher or something, or too much jokes on this one. I'm sorry about that, but okay, I'm sorry about that, and yeah, thank you for listening to my presentation. Goodbye.